Now, when you look at the Trigonometry 1 PDF, it actually doesn't start with trigonometry. It actually starts with a bit of geometry that we know already. And you guys are seeing this, right? Yeah? Hi, Shazay.
Yes, sir.
Shazay and Caitlin. All these ninjas, all the feel all coming in, and I would see all the. Alright. So we start off with just you know, some basic geometry stuff that you guys know already. So when you open the Trigonometry 1 PDF, don't get throwback. I mean, all of this, we did this already. Parallel lines and corresponding angles and such. Some of these questions we did already as well. I'm sure that they would have seemed familiar to you somehow. And of course, we have links to even more questions, right? Am I recording? Yes, I am. Okay. So now today we're going to start with the topic of trigonometry. Now trigonometry, remember when we did geometry, we basically learned everything we had to learn about triangles, but still not everything. Triangles are really wonderful shapes. They are my favorite shape. And triangles make up everything you see in the observable universe, right? So even your body or the table or the chair or the sky or the clouds, they're all made of triangles. And trigonometry is a real cool observation of the right angle triangle, right? So it's all about the right angle triangle. So you can see here we have a right angle triangle, right? And it's really about knowing the sides. It's all about the sides of a right angle triangle. Now, in terms of the sides of a right angle triangle, we know that if this is the right angle here, right, the side opposite the right angle, the side opposite the right angle is the longest side, and that is the hypotenuse. So I'm hoping that we should all know that, right? The hypotenuse is the longest side of a right angle triangle. However, if we consider this angle over here, then we have to know that if we consider in this angle, then the side that is touching that angle would be the adjacent, and adjacent means next to, right? So if it is that is this angle we're looking at, then this side is adjacent to that angle, and this side is opposite that angle. Yeah. However, let's just say it was this angle we were dealing with here, angle theta. Okay. That means that this side, which is touching the angle, would be the adjacent side, and this side would be the opposite side. So it depends in terms of trigonometry, how you're naming your sides depends on which angle you are considering. We always have the right angle here, so we don't really have to worry about that. So it's either this angle or this angle. And of course, we will name the sides depending. Yeah. So we have the angle theta here, right? Somebody just give me this side. All right, I wouldn't use that. Right? Somebody tell me what is A, B, and C in relation to that angle.
B would be opposite.
No, but I like that you tried it. Remember, this is the angle we're looking at. So A is this side, and this is the side that's touching the angle, isn't it?
Yeah.
So it's the side that's next to the angle, right? So A would be what? Look back over here.
Adjacent.
Yes, adjacent, right? And therefore you can see that B is the opposite because it is opposite the angle. It's not touching the angle. Yeah? And of course C is the hypotenuse, right? What about this angle here? And Ariel, I'd like you to try again. this angle here, right? This is A, B, C. Tell me who is who?
A is hypotenuse.
Yes.
B is a side.
This is the angle here we look at.
C is adjacent.
Yes, C is adjacent, which means?
It's touching the angle.
Yes, so that means that what about B?
B would be the opposite.
Very good, right? You want to try one more? Try this one. Yeah, this is the angle here. This is A, B, and C.
B is, oh sorry, sir, I was talking about my classmates.
No problem.
C is opposite, B is adjacent, and A is hypotenuse.
All right. Caitlin, see if you could give me this one from this angle over here. This is A, B, and C.
A is opposite, B is hypotenuse, and C is adjacent.
Yes, so C is the adjacent. It is next to it, right? And what about this one, Shazay? This is the angle here, A, B, and C.
Sorry. A is the adjacent, B is the opposite, and C is the hypotenuse.
Right. A is the adjacent, touching the angle. B is the opposite. C is the hypotenuse, right? Now, why is this important? Because what trigonometry is? Trigonometry is a bunch of ratios. And what do we mean by ratios? A ratio is a fraction, right? So what will happen if we take B and divide it by A? Or what will happen if we take A and divide it by C? Magical things happen when we do this. Magical things happen, right? So let's see what magical things happen. Oh, come on, stop it. Right? So we have a right angle triangle over here, and of course we see that this is the angle theta that we're dealing with. We have the hypotenuse, the adjacent, and the opposite. And what we realize is that certain ratios have certain properties, right? And we name these properties different things. So the first ratio is the sine of the angle. The sine of the angle, if we wanted to find the sine of the angle, you would have to just take the opposite side and divide it by the hypotenuse, right? So sine, the sine of any angle is opposite over hypotenuse, right? Then we have the cosine. The cosine of the angle is the ratio of the, if you take the adjacent side and you divide it by the hypotenuse, right? So if you take the adjacent, you divide it by the hypotenuse, adjacent over hypotenuse, that is cosine. And then you have the tangent of the same angle. Remember, it's just one angle we're talking about here, right? And how do we get the tangent of the angle? Is we take the ratio of the opposite and we divide it by the adjacent, and that will give us the tangent of the angle. Now you see this here, you had to know this by heart, and you have to know it by heart. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Are there any ways that, or any easy ways that we could try to remember this? Any easy ways that you guys know? SOHCAHTOA, right? So, sine is opposite over hypotenuse, that is so. Cosine is adjacent over hypotenuse. And then TOA, tangent is opposite over adjacent, right? So this is one way, all right? Just remember SOHCAHTOA and you should be able to remember it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. the tan is opposite over adjacent, right? So this is one way to remember it. Any other way? It have this one, oh hell, another hour of arithmetic. You all ever heard that one? No?
No, sir.
Nope.
Yeah, so that is that is the one that I learned actually. I never knew the SOHCAHTOA one growing up. Growing up, I find the SOHCAHTOA one is a lot easier though. Especially since I like SOHCAH, you know. But the oh hell another hour of arithmetic is the one that I grew up with, right? Which is kind of lame, honestly, right? Now let's just see what these ratios are about. Remember, if it is that we take the we're dealing with this angle here and the relationship of the sides. These sides, remember we were talking about how this angle determines how long the opposite side is. Remember we were talking about that? Okay. So we were saying that if the angle is smaller, if it was a smaller angle, then the opposite side would be shorter. So we could see that the opposite side has some relation to the angle, right? But what trigonometry is suggesting is that all of the sides have some relation to the angle, yeah? And this is the relation to the angle, the specific angle, right? Is that if you were to take the opposite side and divide it by the hypotenuse, you would get a ratio that would describe the sine of the angle, or the cosine of the angle, or the tan of the angle. So people like Ariel who haven't seen this in a while, remember SOHCAHTOA. Now let's see what these ratios are about now, right? So you can see here that we have a triangle. This is the angle that we're dealing with here, right? We see here that the hypotenuse is 10, the opposite is 5, and the adjacent is 8.66. So let's see what the different ratios tell us, right? So the sine, right, is the ratio of the opposite over the hypotenuse, right? So if we take the opposite 5 and put it over the hypotenuse 10, that is a half, 0.5. So therefore the sine of the angle is 0.5. We don't know what the angle is yet, but we could use this to find what the angle is. So trigonometry is really helpful, because if you don't know none of the angles in the triangle at all, you could actually use the sides to find what the angle is, right? Now cosine, and I hope you guys are writing this down, right? The cosine of the same angle, the same angle we're dealing with here. So the cosine of the same angle is the adjacent, which is 8.66, over the hypotenuse, which is 10, right? So the adjacent over the hypotenuse, the cos of the angle is 0.866. Remember, we haven't found the angle yet, right? We don't know what the angle is, but we found the sine of the angle, which is opposite over hypotenuse. We found the cosine of the angle, which is adjacent over hypotenuse, right? And now we will see what the tangent of the angle is. That is opposite over adjacent, which is 5 divided by 8.66, 0.577. So remember, we have not found the actual angle yet. We still don't know. All we know is that the sine of the angle is 0.5, the cosine of the angle is 0.866, the tan of the angle is 0.577. Right? So can I move on to the next one? You guys wrote this down? Can I move on?
Yes, sir.
Any questions so far? No? Okay.
Nope.
Right? So let's see what that actually means. We know that the sine of the angle is 0.5. So how do we find the angle itself? Well, it have no algebra really to do it. We have to go to the calculator. So if you want to find what the angle is, and everybody just look on your calculator and you'll see a sine, cosine, and tan buttons, right? And above the sine, cosine, and tan buttons, you will see sine inverse. That is that sine to the -1 kind of thing, right? And cos inverse and tan inverse. You guys seeing that?
Yes, sir.
Ariel, you seeing it?
Yes, sir.
Right? So if we have that the sine of the angle is equal to 0.5, you could think about taking sine and throwing it across so that you just have the angle alone. Yeah? So just the angle alone is equal to, when we throw sine across, it becomes the sine inverse of 0.5. And everybody just type in, you'll have to type second function sine inverse 0.5 and tell me if you get 30.
Yes, sir.
Right? So
Yes, sir.
that is 30 degrees, right? So I hope everybody cool with this so far. Now, we found the cosine of the angle to be 0.866. So everybody find the cos inverse and tell me what the angle is.
59.9.
No, all right, not right, not quite. Remember, it's the same angle we're talking about. So see if you did it correctly, because if you just press cos of 0.866, you would have get 0.999 or something ever, right? What you need to do is you need to press second function and then cos inverse, and then 0.866, and tell me what's that equal to. 30. And it makes sense because it's the same angle that we're talking about then. Yeah, so it's the same angle that we're talking about, so be careful how you use those calculators, right? So the cos inverse of that, remember how we got the cos is we took the adjacent and divided by the hypotenuse, and that gave us 0.866. And now we could find the angle by going to our calculators and using cos inverse. Ariel, you okay with this process?
Yes, sir.
Right? And same thing with the tan. Ariel, try the tan and tell me where you get. And of course, you know you're supposed to get 30, right? There's the tan inverse. So second function, tan inverse of 0.577. Ariel, you get almost 30?
Yeah, 29.9.
Yes, all right, good. Now, what is this actually about? This seems like a bunch of gibberish. Well, these are actually really amazing ratios here, and that is what it is. This is a ratio. Just remember that. This is the ratio of the opposite over the hypotenuse, right? So imagine now that what they're trying to tell me is that the sine of 30 degrees is 0.5, right? Sine theta is equal to 0.5. That means that the sine of 30 degrees is equal to 0.5. So, see if you could just go and punch in sine 30. No second function this time. Sine 30 and tell me if you get 0.5.
Got it.
Right. Now, what does that mean actually? Remember what this is. This is the ratio of the opposite over the hypotenuse, right? So that means that, let's just say we have a triangle like this, and that is 30 degrees here, right? This is the opposite, and this is the hypotenuse. If I take the opposite and I divide it by the hypotenuse, I'm gonna get 0.5. No problem. But if I extend this like this, right? So now this is the opposite, this is the hypotenuse here, right? If I take this longer one and divide it by this, because this angle is 30 degrees, it means that I'm still gonna get 0.5. And if it is, that is a huge thing. It could be, if this is 30 degrees, and these lines go out into space, like this is the Earth 30 degrees, this is the Sun and then you come so, and over here is Saturn or something so, you know, and you take the distance from the Sun to Saturn, and you take this distance here, you are going to get 0.5 every time. Yeah. So at the end of the day, this is a really interesting ratio. No matter how big or small the triangle is, the sine of a 30-degree angle will always be 0.5. That means that the ratio, no matter how big the triangle is, right? If you have a 30-degree angle, the ratio of this opposite to the hypotenuse will always be 0.5, no matter how big or small the triangle is. Yeah. So this is the amazing thing about trigonometry and this sine, cosine, tan, is that these ratios, so the cos of 30 degrees, which is the ratio of the adjacent over the hypotenuse, will always be 0.866. No matter how big or small the triangle is, if it's a 30-degree angle and you divide the adjacent with the hypotenuse, you will get 0.866, right? So let's see if you guys could do a couple of small little things, right? We have the tan of an angle, and that is to give us the tan of the angle, and we have to find the angle. So in order to find the angle A, I have to get the tan inverse of 2.0503, and that means I have to go to my calculator. Tan inverse of 2.0503, and that is 63.9. So let me call it 64 degrees. So a 64-degree angle, the tan of 64 degrees is 2.050, right? So this is just a real quick calculator exercise. So Ariel, take these two, Soraya and Caitlin, take these two, Shazia and Scotia, or you could fight over this one. The one who survives the fight will get to answer the question, right?
Number 2 is 83 degrees.
All right, let's see. Just now, where is my pen? Okay, so the angle Z is the cos inverse of 0.1219, which is the cos inverse. 0.1219 is 83 degrees, around there, yes. This one, u is equal to the sine inverse of 0.8746, which is
60.
So the sine inverse of 0.8746, and
61.
Yeah, about 61. Right?
Yeah.
Soraya, what is this one? Hello, Soraya, your mic giving problems again? While we're waiting for Soraya, Kate. Sorry?
And not giving problems, you see.
Oh, you was just sleeping.
No,
it's okay
I
to
was
say.
not sleeping.
It's okay to say.
How would I sleep for
It's
like 2
okay.
minutes?
Hey, Soraya, it's alright. It's okay. It's okay. Alright, don't worry. You don't have to be ashamed of it. Right? Did you get this? What is it?
It's a few minutes.
You're fuming? This is how it is be when you fuming, for real? Alright, while we're waiting on Soraya's answer to that question, Caitlin, you have this one?
What is that one?
Alright, so V is equal to the cos inverse of 0.6820. Let me just check it. The cos inverse of 0.6820 is 47 degrees, around that. The Y, what is Y degrees?
Is it 33 degrees?
The tan inverse of 0.6494. Scotia, did you get that?
Oh,
0.6494. Yes, it is around 33 degrees. Yes. And Soraya, back to you. Did she fall asleep again?
No, sir, I forgot how to do one calculator.
Right. All right. So, well, that's good. That's the purpose of this class, right? So, at the end of the day, remember you have the calculator in front of you, right?
Yeah.
All right. So you'll see a sine button, a cos button, and a tan button, right? And those aren't really the buttons you're using. On top of the buttons on the calculator itself, you'll see sine inverse, cos inverse, tan inverse. They'll probably be written in a different color. So what you had to do is you had to press second function. Then the second function just give you access to the inverse. Then you had to press, if it's sine, well, it's sine you're going for, so you had to press the sine button for sine inverse. And then you had to type in 0.2756. So try that and see what you get. Second function, sine inverse. Huh?
Yeah, I got 15.9.
Yes, 6, and that's 15.9. Let me say 16 degrees, right? Now, Soraya, you understand how to do this stuff, right?
Yeah.
All right. Now that you understand, do me a favor. I'll wait 1 minute. Try these two and see if you get the answers there. This one is a cos and this one is a sine. Right? So the cos inverse of this number and the sine inverse of this number, and see if you get that. We'll wait.
Yeah, so number 2, like, well, approximately 82.
Mm-hmm.
Number 4?
Yes. Try number 4 and see.
Yeah, approximately 60.
Right, very good. And you could see here that this here, we use sine inverse when we don't know the angle, right? So when we don't know the angle, like tan A, we don't know the angle, right? What is tan? Tan is opposite over adjacent. So if we don't know the angle, we could take the opposite side divided by the adjacent side in order to get that ratio. Yeah, and then we could use the tan inverse on the calculator to actually get the angle. Everybody cool with this? Any questions? Caitlin, you okay? Ariel?
Yes, sir.
Alright. Ariel, I think you should be familiar with this stuff, right?
We actually did like trigonometry in school.
Yes. And imagine this have so many applications you wouldn't believe, but we'll see some of them, right? Now, this here is for when we don't know the angle. Right, so we see here that we have a couple. Let's try Ariel, Soraya, Scotia, Shazee. That's pretty cool. And Caitlin. Right. So I'll give you all 2 minutes. What we want to find what that angle is there, and of course you have to look at what you have. You have to look at the sides that you have, identify those sides, and then decide which one of the ratios you want to use, whether it's sine, cosine, or tan. Which one of those ratios you want to use?
Sir, I got the first one. It's 42.6.
42.6. All right, let's just see. I will do it here and let's just see if you got it correct, right? So this is the angle I'm looking for. So what do I have? Well, I could see that this side is opposite right? And this side here is the hypotenuse. So I have the opposite and the hypotenuse. So what I will do is on the side, I will just go and write SOHCAHTOA. SOHCAHTOA. Okay, I can write it like that. Right? And I can see that the opposite and the hypotenuse is sine that is using that. So I could say, well, okay, the sine of the angle is the opposite divided by the hypotenuse. Right? So therefore the sine of the angle is the opposite being 51 divided by the hypotenuse being 55, which is 51 divided by 55, 0.927. Let's take it around there. And now I have the sine of the angle is 0.927, so the angle itself will be the sine inverse of 0.927. So the sine inverse of the answer gives me, ooh, I didn't get that at all. The sine,
So because I use tan.
Alright, and why you use tan? The sine inverse of 0.927. Yes, so it's actually 68 degrees, right? So you see what's going on here, Ariel. The first thing I did was I wrote this, right? And then I check and I see which are the sides that I have. Well, in relation to the angle, I have the opposite side and I have the hypotenuse, right? For tan, you need the opposite side and you need the adjacent. This is the adjacent under here. I certainly don't have that. Yeah? So I have the opposite and the hypotenuse, right? So that is why I decided to use sine. You understand, Ariel?
Yes, sir.
Right. So Ariel, while I'm doing the others, you could try to do this one and see how you work that one. Right? Of course, write this down. It's actually 68 degrees is the answer. Theta is 68 degrees, right? Soraya, you finish yours?
Yeah.
Okay. So what did you get?
I got 44.6 degrees.
Alright, so let's see. So we're looking at this angle here, and we can see, well, what are the sides we have? We have the opposite, because it's opposite to the angle, and this is the hypotenuse again. So we have the opposite and the hypotenuse, that is sine. So therefore sine theta is equal to the opposite over the hypotenuse. So therefore sine theta is equal to 19 divided by 27, which is 0.7037. Let's take it like that, right? So therefore theta is the sine inverse of 0.7037. Theta is, so the sine inverse of the answer, 44.7. Good job. So excellent job there. Scotia, you finish yours?
Yeah.
All right. So what did you get?
I got 38.2.
38.2. So let's see, we're dealing with this angle, and again, it looked like all of these questions are sine boy, right? No, these two are not sine actually, but these first four are actually sine because we have the opposite and the hypotenuse. So you can see here, Ariel, that you can't just go and use any one. You had to look and see what is the sides that you have and then choose which one to use based on the sides that you have, right? So we have here the sine of theta is equal to opposite, which is 34, over the hypotenuse, which is 55. 34 divided by 55 is equal to, oh, that, okay. So therefore that is 0.618, right? So therefore theta is the sine inverse of 0.618, which is the sine inverse of 0.61, no, sine inverse 0.618 is 38.2 degrees. Good job. Shazzy, you did this one?
Yes, sir.
What you got?
35.66 degrees.
35.6. Well, let's see. This is another sine because we can see this is the opposite and this is the hypotenuse. So we have sine. Sine theta is equal to the opposite 14 over the hypotenuse 24. Right? So 14 divided by 24 gives us 0.5833. Right? So theta is equal to the sine inverse of that 0.5833, which is the sine inverse of 0.5833 is 35.68. Pretty cool. Alright. Caitlin, did you get this one? Is not sine. So let's see how Caitlin does with this.
I got 37.3.
37.3. And what did you use?
Thank you.
Tan. This one is the tan. So we can see here, this is the angle that we're going for. This is the opposite side. And this here is the adjacent side. So if we look at our SOHCAHTOA, we see that tan uses opposite and adjacent. So we go tan theta equals opposite, which is 29, over the adjacent, which is 38. That gives us 0.7631. Right? So now theta is equal to the tan inverse of 0.7631. So the tan inverse of the answer is 37.3 exactly degrees. Good job, Caitlin. Ariel, your time has come to redeem yourself. What did you get for this answer?
I got 68.1 degrees.
Alright, so it's the same as the pretty much. Okay, alright, 68.1 degrees. What did you use for it?
Tan.
Right, so we could see here that we have the opposite of the angle and we have the adjacent of the angle. So the tan theta, notice how I always writing it with a certain order. I always stating first that tan theta is opposite over adjacent. I always stating what it is. Then 8 over 20, right? Which is 8 divided by 20 is 0.4. So therefore,
Wait,
huh?
so I do 20 over 8.
Right, so you see here TOA is TOA, and this is why I wrote it like this, TOA, right? Opposite over adjacent. Yeah, you see what's going on? Yeah?
Yes, sir, my bad.
Yeah, so SOH is opposite over hypotenuse, right? So the tan inverse theta is the tan inverse of 0.4, which is, the tan inverse of 0.4 is 21.8 degrees, right? Now I'll tell you something, Ariel, you'll owe me some questions here for this, right? Because it's some careless mistakes that you're making, right? So you'll definitely owe me some questions, and the reason why I wouldn't let up is because it don't just, trigonometry is a kind of thing where it don't just have one trigonometry question, you know? It has so much application. So yeah, you'll have your trigonometry question, yes, but then you're gonna have to use trigonometry in a coordinate geometry question. And then you might have to use trigonometry in a bearings question. And you might have to use trigonometry in a circle theory question. You understand? So, at the end of the day, this trigonometry stuff is super important. So, I definitely want us to master it, right? Now, we could see here, this is a different kind of thing. We could see that all of these problems here, we didn't have the angle. We didn't have the angle, and we wanted to find the angle, right? But look at these questions here. With these questions, we have the angle. We have the angle, but we want to find one of the sides. So it's the same kind of thing. I'll go and write SOHCAHTOA here. SOHCAHTOA. Right? And now let me see. The angle, this is the angle theta, 37 degrees. What are the sides that we have? Well, this side is the adjacent side, and this side is the hypotenuse. So I could see here that I want to actually find the hypotenuse, yeah, because I don't know what the hypotenuse is. So I have adjacent and hypotenuse. Ariel, which one of the tricks should I use? Yes, cosine, because we have adjacent and hypotenuse. So these are the sides we're dealing with. We have nothing with opposites, so we can't use sine, we can't use tan, right? So the cos of the angle is equal to adjacent over hypotenuse. So we can see here that we have the cos and we have the angle 37. And that is the adjacent, which is 11 over the hypotenuse. Right? So we can actually go now, and this is not a cos inverse situation. This is just cos. So go to your calculators and don't press no second function, just literally press now cosine of 37 and tell me what you get. Soraya, let me know what you get for the cosine of 37. That's if Soraya didn't fall asleep or watching Netflix.
I get 0.798.
Very good. Ariel, do you confirm that?
Yes, sir, got this in there.
Right. So the cos of 37 is 0.798. And think about that for a minute. We just typed in cos of an angle. We got 0.798. So what that tells me is no matter how big the triangle is, if I divide the adjacent by the hypotenuse, I will get that number, right? And that is equal to the adjacent over the hypotenuse. I want to find the hypotenuse. So what I'll do is I'll fling the hypotenuse across. So now the h is going to be multiplied by the 0.798, and that is going to be equal to 11. Yeah. And now I could take the 0.798 and fling it across. So now h is going to be equal to 11 divided by 0.798. So you can see some algebra is involved here, right? And 11 divided by 0.798 is 13.7. So h is equal to 13.78. And that is x, that is the hypotenuse, right? Okay, so both of you guys. All right, so let's just see what everybody did wrong or right or whatever, right? So we can see here that we want to find this side, and this is the angle that we have. So this here is the adjacent to the angle, because it's next to the angle. And this side here is the opposite of the angle, right? So the hypotenuse, we don't have nothing to do with that, right? So we have the adjacent, we want to find the opposite. Opposite and adjacent is tan. So I will come and say, well, okay, the tan of 32 is equal to the opposite, which is x. X is the opposite over the adjacent, which is 13. Nice. So actually, if I want, I could fling across the 13 one time. So I could say 13 multiplied by the tan of 32 is equal to x. And I don't have nothing for me to do, is just work that out, right? So 13 multiplied by, press tan 32 on my calculator, and I got 0.624. That is x. So therefore x is 13 multiplied by 0.624, which is 8.1. 1. Yeah. So let me ask you something, Ariel. What did you do wrong here?
So, I made the same mistake, settling over 0.4.
But you understand what you do wrong there so far, right?
Yeah.
You understand. You sure? Right?
Yeah.
So you can see you had to be real careful here. Yeah, when it comes to identifying your side. And usually in trigonometry, the biggest problem is be identifying the sides, the correct sides, and using the correct ratio, right? So let's just see who wins between Scotia and Soraya. I think I know who might be the winner here. So we have this angle here, and when we come to this angle, this side is the adjacent side, and we can see that this side is the hypotenuse, right? So adjacent and hypotenuse, that means it's cosine I have to use here. So the cos of the angle 60 is equal to adjacent over hypotenuse. The cos of 60 is equal to the adjacent, which is x, that's what we want to find, over the hypotenuse, which is 11. And this is another case where I could just throw the 11 across. So I'll get 11 multiplied by the cos of 60, and that is x. So therefore x is equal to 11 multiplied by the cos of 60 is 0.5. So what is a half of 11? That is 5.5, yes. So 11 multiplied by 0.5, x is indeed 5.5, right? So Scotia, good job, Soraya. Scotia, you realize that you too, just like Ariel, you chose the wrong ratio, right?
For my own.
For yours over here, you divide. Well, that's because you had them on the wrong thing. Because if x was on the underneath, then you would have to divide. Yeah, because that means that you would have bring x, so you would have x over here, so you would end up with x tan 32, and then you would have had to carry the tan 32 across, so x would have been the 13 divided by the tan of 32, and
yeah,
that is what you did, right? So yeah, if you had the x at the bottom, yes, you would have definitely had to divide instead. Yes, so it's not, so your algebra actually wasn't wrong there. Your algebra was correct. The mistake that you make was before that. It was actually the mistake that you made was identifying the sides. Your algebra was totally correct, because if the sides were correct, then yes, you would have had to divide, right? Yeah. So anyways, right, we see that this is the angle here, right? 50.1 degrees. So this side is obviously adjacent to the angle, and this is opposite to the angle. So we have to use tan. So the tan of 50.1 degrees is equal to opposite over adjacent. So my tan of 50.1 degrees is equal to the opposite, which is what we want to find, that is x, all over the adjacent, which is what we have, which is 5. So again, we don't have any dividing to do because we can just throw across the 5. So it'll become 5 multiplied by the tan of 50.1. And I'm sorry for the scrappy writing. PowerPoint does have a real crappy kind of pen thing that writes very scrappily. So the tan of 50.1 is 1.19. 1.196 multiplied by 5 will give me x, and so x is equal to that multiplied by 5. 5.9. No, you get it right. Caitlin, what you do? Well, yeah, Caitlin, you was off by a lot. Caitlin, what you do? So you had 5 over x. Yeah, so you do the same thing that Ariel did. Yeah. So the identification of your sides and matching it correctly with the trig ratio, right? So I'm glad that we did these questions because we all kind of got to see how how tricky it is sometimes, even though it's a pretty simple thing. The careless mistakes can be made. Ariel, Soraya, Scotia, Shizzy, Caitlin, you all understand this stuff?
Yes, sir.
Yes, sir.
Right. So you can see over here, we use trigs to find the angle. We have two sides, we need to find the angle, right? So, so in this case, when you had to find the angle, obviously the angle gonna end up by itself, so that is when you had to use sine inverse, yeah, or cos inverse or whatever. In this case, we have the angle, so when you have the angle, you can just type in the cos of the angle. You don't need to find the angle. So you have the angle is one of the sides that we had to find, and we see in here how absolutely imperative it is for you to identify the correct sides and identify the correct ratio to use. Right? So we have some Kuta Software stuff here, and these two Kuta Software. So this is the first link. So we could see here that we had some of these questions that we did. I expect everybody to do all of the questions. In this one, find the measure of the angle. So you have to find the angle, and we have a lot more questions here in terms of choosing the right trig ratio. Now let me tell you, I expect everybody, my Form 4s and Thing 2, to do these questions simply because trigs is a super important topic. As I say, it don't really have a trigs question. Trigs is something that could pop up in all sorts of different topics, and you can see we have the answers here. Alright, so you have your answers. Even though they have the answers though, trigs is such an important topic that we are definitely going to be doing all of these on Saturday. So I'll expect everybody to have it. This is the second link. And this link here, you can see that we have some questions where you have to find the angle, and then some questions you're given the angle and you have to find a side, right? And solve each triangle. Round answers to the nearest tenth. What do they mean by solve the triangle? Find the measure of the side. Let me see what they mean by solve each triangle. I'll look at the answer. Oh, nice. That's nice. Lovely. I love this. So solve each triangle means, let's take a look at this one, for example. Right? This here is 62 degrees. So, and you see that you have the angle 62 and you have the opposite side. In order to solve the triangle, you have to find all three sides. So you have to find what is the adjacent side. So adjacent and opposite, that is tan. And then you have to find what is the hypotenuse. So hypotenuse and opposite is sine. So you'll have to use numerous trig ratios in order to find all of the sides in order to solve the triangle. And you can see here we solve, to solve the triangle you have to find all the missing sides and all the missing angles as well. That is lovely. Very, very lovely. So you're going to use trigonometry to solve the triangle. Right? Everybody understands what they have to do? This we have, this is just on this, you all seeing this? Yeah? Okay, yeah, good. We have here angles of elevation and depression. CSEC loves to bring these types of questions here. Angles of elevation and depression. So imagine now you are looking up at a flag, right? Let me just say the flag is mounted on a rock, right? You have to be really careful. Alright, let me just say the flag, the flag mounted on a rock, right? You had to be really careful because you had to understand that this forms, you looking at the flag forms a right angle triangle. But it forms a right angle triangle from the level of your eyes. So if this is your eye level here, right? And this is the eye level at the base of the flag. And then this is when you look up at the top of the flag. And we have this angle here, and that is the angle of you actually looking up. And I actually had my Form 3s build something called a clinometer. And what they do is they just take a straw and you tape a protractor onto it with the angles. You know how a protractor does look, right? And then you, at the middle of the zero line, you just tie like a coin or something. And you know, as you look through the straw, right? And when you look through the straw, if you're looking up like that, then obviously the straw going to be facing up like that. So this will be the protractor here, but the string is going to be hanging down like that. So you can actually measure this angle here, and that will be the same as the angle that you are looking up at. So this is called a clinometer, and I let my Form 3 students build it, but we don't have time for them kind of thing. So at the end of the day, the angle of elevation is the angle that you are looking up at. So you could use this angle, and they'll give you this distance here, right? And then they'll give you this angle here, and what they'll tell you have to do is you have to find the height of the flag. Yeah? So that is a question that we do. They give you an angle of depression is the same thing. You're looking down, you're on a cliff, and you're looking down at a boat in the water, right? And of course you have the horizontal from your eye level. This is the 90-degree angle here, so this is the angle of depression. And what they might ask you is, they might tell you, well, the cliff is this amount high. The cliff is 10 kilometers high, right? Find how far away the boat is from you. Yeah. So if you're standing on a cliff and you know how high the cliff is, you can look down at a boat and you can measure this angle using a clinometer, and you can actually calculate how far the boat is away from you. Or if you know how far the boat is away from you and you know the angle of depression, then you can actually find how tall the cliff is. Yeah. Now, does everybody understand how trigonometry applies to angles of elevation and depression? Are you all okay with this?
Yes, sir.
All right. Okay. Well, that is a yes, sir, right? That's a yes, sir. Now, if all you're okay with this, have fun. So, I mean, it's written kind of crazy, but what they're trying to say is this angle is 65 degrees, and this angle is 30 degrees. Right? Even though it's written kind of on the outside there, that's like a computer error or something. So this angle is 65 degrees. This angle is 30 degrees. In the figure above, calculate the length of AB. So this here. And they'll give you a hint. First, well, they give away the answer here. First, find FA, and then find FB and subtract it, right? Well, they basically give away the answer there. Oh gosh. You have 5 minutes. So obviously we have to find AB, and they actually tell us what to do. They tell us find FA and then find FB, right? And if we find FA and then we find FB and we subtract that, we'll be left with AB or BA, however you want to get it. Okay. So let's do what they say. They actually tell us find FA. So let's find FA. We can see FA is the base of this large triangle here. It's a right angle triangle. FA is the base. The angle for this is 30 degrees. Right? FA is adjacent to the 30 degrees. And then the only other side we have is this, which is opposite to the 30 degrees. Right? So in order to find FA, I am going to use, well, let me write down SOHCAHTOA. You should probably write this down. Once you see a trig question, write that down in the corner. Right? Don't stick with writing that down. Yeah, write it down. It'll help. So we see here that we have to use tan, opposite over adjacent. So the tan of 30 degrees equals opposite, which is 6, over the adjacent, which is FA. Yeah? So FA is what I want to find, right? So I will throw the FA over. So now I'll have FA multiply by the tan of 30 is equal to 6. And now I'll take the tan of 30 and throw that over. So now I'll have FA is equal to 6 divided by the tan of 30, which is 6 divided by the tan of 30 works out being 0.577. So now FA is 6 divided by 0.577, which is 10.39. Okay. So Ariel, you understand what I did here?
Yes, sir.
It makes sense to you?
Yeah.
And is it that you chose the wrong ratio?
Yep.
And which one you took?
To find FA, I chose sine.
Right. So you're seeing here that we have the opposite, but this here can't be the hypotenuse because look the right angle here. Yeah? So if that is the right angle, then this is the hypotenuse, and the hypotenuse is the longest side, and right?
Yeah.
So obviously this side here is adjacent to the 30, and then the 6 is opposite to the 30, right? So we see in here, Ariel, that one of your biggest problems is identifying the sides that you have to use, right? So we found FA, which is the long one. FA is 10.39. Shazay and Caitlin, did you get that for FA?
Well, I now see that multiply instead of dividing.
But you see why the divide happened though?
Yeah.
Yeah? You see
I
why?
don't know. I was watching it at first, and then I tried to divide it, and I get a number. It was like 0 point something, and I thought that looked weird, so that's why I multiplied instead.
Right. But look at the process. All I did, it wasn't a question for me of should I multiply, should I divide? You know, I never had that question. Because look at the process. What did I do? I put the tan of 30 equals opposite over adjacent. And
yes, sir.
that's the first thing you put. And then, well, I know this is what I want to find here, and it's in the denominator. So what I need to do is make that the subject to the formula. Right? So that is why I fling it across on this side, because I want it to be the subject of the formula. That's what I want to end up with. So it's divide over here. When you fling it across, it'll become multiply over here. It'll be multiplied by the tan of 30. And then I could get rid of the tan of 30 by flinging that across. Now over here, it's multiplied by the tan of 30. So when I fling it across, it'll become divide by the tan of 30. So to me, it was not a matter of wondering if I should multiply or divide. It was a matter of me making a correct first statement and following the algebra clearly from one step to the next. Yeah? Following the algebra clearly, making sure that every single move that I make is a correct move. I know that I want the FA to be the subject of the formula, so I'm flinging it across on the next side. And if it's divide on this side, it'll become multiply on this side. Ariel, you okay with this? Like, kind of. You understand what I did here? Would you like me to do it over?
No, I understand from the process, yes.
What about Soraya? You okay with this?
Yeah.
Alright. That sounds really, you sound totally excited here, right? So
Yeah.
yeah, good. That's a lot better. So we found FA and we saw that FA was part of the big triangle, right? Now they told us to find FB, and FB is part of this small triangle over here, right? So we could see that what we have is this angle 65 degrees. This is the right angle, which means this is the hypotenuse. That means that this is the adjacent, yeah, and this is the opposite. So we're still dealing with opposite and adjacent. So it's still tan we're talking about here. So now we're talking about the tan of 65 because it's the smaller triangle we're talking about. And that is opposite over adjacent. The opposite is 6 and the adjacent is FB, which is the side that we want to find, right? So tan of 65 is equal to 6 over FB. So you see, I identified and make my opening statement clearly. Once you're sure about this opening statement, the rest is just going through the algebra. So I want to get FB to be the subject of the formula. I'll fling it across. It's a divide on this side, so it'll become a multiply on this side. FB tan 65 is equal to 6. Right? Then I want the FB alone. So I take the tan 65 and throw it across. So now FB is equal to 6 divided by the tan of 65, which is 6 divided by the tan of 65 is 2.1. So we call it 2.14. 6 divided by 2.14 gives us, let me do that one more time, 6 divided by 2.14, yeah, is around 2.8. Yeah, so FB is actually 2.8. So we could see here that FA, the long side, is 10.39, and then FB, this short side, is 2.8. So now AB or BA is equal to 10.39 minus 2.8. 10.39 minus 2.8, and that is 7.5, which is way off from the two answers that I got here. Okay? Now at the end of the day, you could see here that all I used was the basic tan ratio. That's it. Yeah. The biggest problem here was seeing the sides. Caitlin, where did you go wrong?
I had the 2.8, it was just FA that gives my problems. I had 2.5, so that was I only had 0.5 for when I did the tangent, so it kind of mixed up.
So is it that you had 6 divided by the tan of 30? You had that?
Yeah.
And you just went 6 divided by 0.5?
Yeah.
Right, so you had to be careful because that is 12. And look at the big difference there. 6 divided by 0.5 is 12. And 6 divided by 0.577 is 10.39. That's a huge difference, right? So yeah, you definitely want to try to be as exact as possible. Try not to round it down too much. Use as much decimal places as possible. Ariel, do you understand what went on here?
Yes, sir. So I was on the right track with FB using tan. I don't know why I used sine for FA, but
and it was pretty much the same triangle, right?
yeah.
Right. Yes. Very good. Right. Soraya, how you feel about it?
Mixed feelings. I kind of messed up from the start because I didn't use tan with FA, and then it kind of mixed with FB, and then everything just went silent. But I kind of understand what you did now.
So you understand what I did now. I hope you write it down, right? So, okay, so we could see here, and that's the thing, right? Trigonometry questions come in many shapes and forms. They could bring all kind of madness for you, but all you really have to remember is SOHCAHTOA, and you just have to remember to identify it's a right angle triangle you're dealing with. It will always be a right angle triangle. So identify the sides that you're talking about here. So we have, let's do this one, number 2. Right? Angles of elevation and depression. Let's just do number 2. So, I mean, of course, they love to bring these kinds of questions for CSEC, especially written questions. So let's do number 2. And I'll give you guys, it's 46 now. I'll give you all 5 minutes. Alright, or I'll give you all a little more than 5 minutes. Now you all should have kind of have a diagram going by now. And just in case you guys got a wrong diagram, I'll see if I could draw a sketch of what the diagram you're supposed to have is. The flagpole is 20 meters high, so that is 20, right? The angle of elevation of its top from point A on level ground. So from level ground here, this is level ground. So obviously this is 90 degrees, right? And from a point A, the angle of elevation is 37 degrees. So the angle of elevation, that's if you're looking at the top, this is 37 degrees, right? And then from a point B, the angle of elevation is 52 degrees. So from the point B, looking up, the angle, this is the point B, and the angle of elevation is 52 degrees, right? Calculate the distance AB, which is here to here, this distance here. And as you can see from the diagram, it's the same kind of question that we saw before. So let's just see, right? It's the same kind of thing as before. What we could do is we could find this long side first, then we could find this short side after, and when we minus it, we will be left with AB. So that is what we're going to try to do. And of course, they didn't tell you no hint this time, so you kind of had to try to figure it out, right? So let's find the long side first. And the long side is the side that comes from the big triangle, right? And let me stop being so horrible and scrappy, even though it's kind of too late. But the big triangle here is what we're looking at to find the long side, right? So this long side, we're using the big triangle, and the big triangle is using this angle here. We could see that the side we want to find is the adjacent side, because this is the hypotenuse over here. So therefore, this is the opposite, right? So in terms of the big triangle, this is the opposite, this is the adjacent, and the hypotenuse. We can see we want to find the adjacent, so we'll have to use, remember, always write on the side here, just in case, right? So we want to use opposite and adjacent tan. So the tan, we want to use opposite and adjacent tan. So the tan of 37 is equal to opposite over adjacent. So the tan of 37 is equal to the opposite. We have that is 20 over the adjacent, which we want to find, which is the long side, right? So we carry the a across, so a tan 37 is equal to 20, and therefore a is equal to 20 divided by the tan of 37, which is 20 divided by the tan of 37 is 0.754. Right? 3 decimal places is a pretty cool place to be, yeah, especially with these types of questions. Definitely not 1 decimal place. 1 decimal place will give you too big of an error, right? So a is now equal to 20 divided by 0.754 is 26.5. That is what Ariel got. So Ariel, you got the long side 26.5. You understand what you did there, right?
Here.
Nice. Remember, this is the length we want, AB, the length from here to here. Right? So now let's find this length here. And this length is from this smaller triangle. Right? The smaller triangle, we're dealing with 52 degrees. This here would be the adjacent, and this here would be the opposite. And so, adjacent and opposite means we're using the same tan, but this time it would be the tan of 52 degrees is opposite over adjacent. Right? So, we could see there that we want to find the adjacent. So, tan of 52 is the opposite is 20 over the adjacent. So therefore the adjacent by the tan of 52 is equal to 20, and the adjacent is equal to 20 divided by the tan of 52, which is 20 divided by tan of 52 is 1.2799. Let me take that. Right? So therefore A is equal to 20 divided by 1.2799 is 15.62. 626, we could take that. Alright? So we can see here that the long side is 26.5. The short side is 15.626, and so if we minus the 15.626 from this 26, what we have here will be the distance AB. So therefore AB is equal to 26.5 minus 15.626, which is 26.5 minus the answer 10.873. Right? So I would definitely say that this 10.93 would get correct, 10.5 would get correct, 10.9 would get correct. At the end of the day, when you're doing these type of questions, I would suggest for accuracy's sake that you use 3 or even 4 decimal places. Do not use 1 decimal place. So Caitlin, is it that you use 1 decimal place is how you get 10.5?
That's 10.9.
Huh?
That's 10.9.
So so Soraya. So it's Soraya, is it that you use 1 decimal place that you got 10.5?
No.
Yeah. Oh God, Soraya, we done.
I know, but
Well, it feel like I put you through Guantanamo Bay today, right? So, listen guys, at the end of the day, we only did trigonometry 1 today. I actually wanted to finish the whole topic of trigonometry. I actually thought that this part of it would have been easier for you all. We still have trigonometry 2 to do, but we wouldn't do trigonometry 2 until next Tuesday. So what we'll do this Saturday is that we will focus still on trigonometry 1. So all of the questions, these questions here, right? And of course, my Form 3s and Form 4s, I mean, you know, I know that you guys have a lot on your plate with school and stuff, so you mightn't be able to do everything. Form 3s and Form 4s, just do as much as you can, okay? My exam students, however, I expect you to try your best to do everything, because at the end of the day, you need the practice. Trigs is an important topic, right? So get as much practice as you can. So these questions here, all of these questions here, and then we have these 2 Kuta Software, right? So the 2 Kuta Software links, all of the questions in those links, and all of these questions here, right? Which is just these 3, because we already did the rest, so just these 3. So the 2 Kuta Software links, you'll have these 3 questions here, but guess what? That is not all. We have one thing again to do for Saturday. And guess what? It's your favorite topic. Yay! Circle theory. Because remember, it had some theorems that involved trigonometry, right? And those were the theorems after Theorem 5, after Theorem 6. From Theorem 6 is where we're dealing with tangents. And for these questions, note, you will need Pythagoras theorem and trigonometry for these questions. So on Saturday, we will also be looking at these circle theory questions that have to do with tangents. So the questions after Theorem 6. Make sure you write this down. Let's see how many questions there are. You have 2 here, 1, 2, 3, and then 3 more there. So 1, 2, 3, 4, 5, 6. Just 6 circle theory questions is what we will look at. Right? We might look at more of these links on Saturday, but these 6 circle theory questions that might involve trigonometry. It doesn't have to, but it might involve trigonometry.